Okay, so this is the Unit 10 mid-unit review. Number 1, complete the table if needed. Plot the points and sketch the curve for f of x equals x squared. So if you know the vertex, you can plot it. Otherwise, you need to find the vertex, and we can do that by plugging in some points. So if I plug in 0 for x, 0 squared is 0. So I get 0 for f of x as well. If I plug in -1, -1 squared is +1, and 1 squared is +1 as well. We can tell that 0, 0 is our vertex because that will start to be our turning point. It'll be our lowest point on our parabola. Because if I plot 1, 1 and -1, 1, then that means our quadratic function is going to open upward. I can also plot -2 and get -2 squared is 4. +2 squared is 4. So over 2 up 4. Back 2 up 4. We could also tell that our vertex is 0 because I have nothing inside parentheses and nothing added to the end. So in vertex form, our vertex is also 0, 0. That is a minimum because my graph is opening up, and it is the lowest point that I have. My domain is what x values I have. That's all real numbers, because all the x values can be plugged in to x squared. Even if you had 1,000,000, you could plug it in for x squared and get a y value. Your range is what y values that you would get, or what f of x values. And we notice over here on the right that my lowest value out of these is 0. And all of my other y values will be above in the positive y's. So that means my y's start at 0 and have to be greater than or equal to that 0 at the vertex. When you're checking your range will match the y value of your vertex. Your axis of symmetry will match the x value of your vertex. So this is going to be x equals 0. And we're going to see that that's because my axis of symmetry should go straight through my vertex, and it's what cuts it in half to make both sides symmetrical, and the value of x at that point is 0. Okay. For number 2, my vertex can be found from my equation, so I don't necessarily have to plot the points. I take the opposite of the number inside the parentheses and the same as my last number, and plot my vertex of -1, -4. I can determine whether I have a maximum or minimum 2 different ways. The first way is to plot the points, or figure out the coordinate points that are 1 less and 1 more than the x value of my vertex. So I would plug 0 into my equation. 0 plus 1 is 1. 1 squared is 1. 1 times 2 is 2. And 2 minus 4 is -2. Plugging in, and you want to actually show your work on those. Okay, so I add first inside the parentheses. Next comes exponents, then multiplication, then subtraction, and I get -2. Okay, so if you plug in -2, you should also get -2. There's another way you can tell what, oops, that was wrong. Sorry, that should be at -2, -2. and 0, -2. Oh. There we go. So you can tell whether you have a maximum or minimum based off of where, if this parabola is opening up or down. Another way you can tell your maximum or minimum is by your A value. So if your A is a positive number, then your graph will open up. And this is positive, so that gives me a minimum, because if my graph opens up, then there's a bottom of my graph. And then we want to see what points up here also plug in. So I'm going to plug in one more point for each of these. So 1 plus 1 is 2, 2 squared is 4, 4 times 2 is 8, and 8 minus 4 is 4. So my other point on each side is a 4. I'm going to go over to 1, 4, and -3, 4. Then you draw in your function. 2a is asking if 328 is a solution. So you would plug in the number 3 and see if it equals 28. So we're doing 2 times 3 plus 1 squared minus 4. Parentheses first is 3 plus 1 is 4. Then exponents, 4 squared is 16. Then multiplication, 2 times 16 is 32. 32 minus 4 is 28. So we plugged in 3 and we got 28, which was the number we were looking for. So yes, it is a solution. Compare the graph of number 2, which is k of x, to number 1, which is f of x. The second one is wider. I'm sorry. The first one is wider. And you can tell by looking at the graph that this one is wider than the lower one. But you can also tell because of the A values. So my A value for number 2 is 2. My A value for number 1 is 1. If you have a larger A value, that means it stretches your graph vertically, which means it makes it more narrow. So this one's more narrow. You can also check between the first points. So I go over 1 up 2, which is more steep than going over 1 up 1. Okay, so you want to tell me why the A values do that, but when A is greater than 1, the absolute value of A is greater than 1, then we know our graph is narrow. So the wider one would be when it's equal to 1. The 1 and the 4 change the location of the vertex. What did the 1 do to the graph? The 1 sorry, I'm making mistakes. The 1 shifted the graph to the left 1. So we're left 1 from the y-axis. And the 4 shifted it up 4. Name 2 other points that are solutions. So any of these 2 points over here, so you can put negative 3, 4, and you can put negative 2, 2, I'm sorry, negative 2, negative 2. And then down below, we have a solution to solving for x-intercepts. So this is our second equation from above on number 2. And they plugged in a 0 for the y value in order to find the x-intercepts. And you will always do that to find x-intercepts. Okay, but you should always, but in this case, we should have 2 solutions. This graph shows 2 solutions for the x-intercepts. So, because I only got 1 solution. This solution is correct, but we need 2 solutions. So somewhere we went wrong. So when we start, we need to do our order of operations in reverse. So he added 4 to the other side, or she. And that was correct. Next was to divide by 2, and that's correct. Then you take the square root of each side, which is good. But remember, the square root of 2 could be positive or could be negative. So you want a plus or minus the square root of 2 when you take the square root. So that splits off a second piece right here. So we should also have the negative square root of 2 equals x plus 1, just like we had the positive square root of 2 equals x plus 1. So then I add 1 to the other side, and I get x is equal to the negative square root of 2 plus, minus 1. And they did write it a little weird here because they wanted to move the x to the other side. All they did was subtract 1 from each side. So if I subtract 1, I have a negative square root 2 minus 1, and that's what my answer is here. So when you take the negative square root of 2 minus 1, you can approximate the square root of 2. But I already have the approximation right there, so I'm going to do the negative version of that. And then subtract 1. And that should give me negative 2 and 414 thousandths. So there are 2 answers to this. So 2 x-intercepts. And those you can write as points. And those would be the 2 points that were graphed on our